have seen several problems about pigeonhole principles, you might think that all of them are about numbers. Actually, in reality, we could see things about pigeonhole principles in many places. For example, do you know what's in this picture? Well, this is lottery. Actually, in the world of lottery, we could often find some facts by pigeonhole principle. For example, let's take Mark 6 as an example. Every time it will draw 6 numbers from 1 to 49. Also, there is a 7th number as a special number. We all want to know what are the 6 numbers and the special number like. Of course, pigeonhole principle couldn't tell you what they look like, but it could tell you some regular patterns in it. Let's see. Well, let's analyze these award-winning numbers to find the regular patterns in it. We would find that every time among the 6 numbers, at least 2 of them must be the same in their first digits. Is it true? Let's assume that, for example, if we regard the first digit of numbers like the 0, 1, 0, 2 as zeros, we could find that it's true that there must be 2 numbers such that their first digits are the same. Why? Let's analyze it. Every time it will draw 6 numbers. And how many choices are there for first digits? The numbers are from 1 to 49. And the first digits must be 0, 1, 2, 3, or 4. Only 5 choices. 6 numbers are flying into 5 pigeonholes, so there must be 2 of them falling into the same pigeonhole. So we find that there are some regular patterns in the results of lottery, but pigeonhole principle could only tell you that this is a fact. Could it tell you which 2 pigeons are in the same pigeonhole? No. So we often use pigeonhole principle to prove that something must exist, but pigeonhole principle couldn't tell you the exact form of their existence. In the quiz we took, what we did are socks. Now let's make it more complex. We have a total of 20 shirts, and they are in 3 different colors. 4 of them are blue, 7 are gray, and 9 are red. So how many shirts do we need to take to guarantee that 4 are the same color? This problem is a bit more complex than the problem on socks. What should we think about it? Well, a fundamental rule for pigeonhole principle is that something is only a bit larger. There is a feeling of threshold. So let's think that how could we have no 4 shirts with the same color? If we want to have no shirts 4 shirts with the same color, we think that there are 3 colors. And if we want to have no 4 shirts with the same color, we should take at most shirts as possible to have no 4 same colored shirts. So how many shirts should we take? 3 colors. If we take 3 colors for each color, there are no 4 same color shirts. We would find that this is a threshold. If we add 1 more shirt, no matter whether it's blue, gray, or red, any of them would make us have 4 same colored shirts. So with this idea, we could construct 3 pigeonholes for the 3 colors. For the 3 pigeonholes, we want to guarantee that none of them have 4 pigeons. So now we could denote the number with k. K plus 1 equal to 4. Here k is 3. When k is 3, there are n pigeons holes, and k times n is the largest possible number not to satisfy the condition. That's kn. If we have the kn plus 1th shirt, it would guarantee 4 same colored shirts. So the answer is k equal to 3 for kn plus 1. K is 3, n is 3, so kn plus 1 is 10. In this problem, we only need to pick 10 shirts. No matter how we pick them, there must be 4 same colored ones. But let's extend this problem. How many ones do we need to pick to guarantee 5 same color shirts? Look at the problem. We will discover that it's different from the previous problem. There are at most 4 blue shirts, so we couldn't calculate like the 3 times 3 to find the threshold. We still need to take as most as possible. When taking at most shirt as possible, we need to take all the 4 blue shirts at first. Then let's think that if we want to have no 5 same color shirts, it could be 5 4 times 2 in this situation, taking any more shirts would make us have 5 same colored ones. So the answer is 4 plus 4 times 2 plus 1 equal to 13. After taking 13 shirts, we would always have 5 shirts with the same color. So we need to take care of such traps when doing problems.